Hello everyone. So in the last few classes we have seen about what is VPC and what are the different options that are available in VPC, and we have seen subnets and we have seen NAT instances, NAT gateways and all. So there are two more important concepts like which are available in each VPC still. So we'll see the two concepts today. So among them the first one is network access control list, which are called NACLs. So, what are these NACLs and how they are different from the security groups? We'll see today. So, NACLs, as I said, so NACL. So, this NACL stands for Network Access Control List. Okay, so they are like firewalls, they are like security groups, but these security groups or these firewalls, they are given on a subnet level. Okay, so the security groups which we used earlier, so we used to give them on EC2 instance level, right? But here the NACLs are like firewalls which control the traffic from and to subnets. Okay, so one NACL per one subnet. So we can assign one NACL per one subnet. Okay, so new subnets are assigned to the default NACLs. Okay, so how we'll define these NACLs, we'll see. So these NACLs consist of some rules, rule numbers. Okay, so this rule number starts from 1 to 32,766. Okay, the higher preceding with a lower number. That means if you this comes in a sequential order. So if you give any 10 rules, so what happens is based on this rule number. Okay, it will start checking all the IPs or all the firewall rules, and when you give any lower number rule in this knuckle, so it will pick that lower number, and it will proceed with this. For example, if you give so if you allow your IP to access SSH port on knuckle on rule number 100, okay, so in the same knuckle if you give the same IP to deny, okay, in rule number 150, so it will come in a sequential order, and in the order number like 100 there is a rule which allows the SSH port 20, so 22, so it proceeds with the first rule instead of going to the 150th rule and denying it. So it allows the rule because the 100 is lesser than 150, it goes with the allow rule. So we'll see it hands on, don't worry about it. The first rule match will drive the decision. So the first rule which matches, okay, will drive the decision. Example. So if you define 100 and allow, so this particular IP, okay, so in the 100 serial number, okay, if you allow this IP, and in the 200 if you deny this IP, okay, so what happens is the IP will be allowed because 100 has the higher precedence over 200 because it comes in a sequential order and checks here, and it says like this particular okay cider is allowed, then it allows, it won't go to here and denies it, okay, because it has the lower number. The rule, the last rule is a asterisk, so that denies all the requests in case of no rule is matched. Okay, so if you give star, that means it denies all the requests. Okay, so AWS recommend adding rules by increment of 100. So AWS always recommends to add your rule starting from 100, because if you want to add any other rules above this, then you can use the before numbers from 1 to 99, you can use that. So if you are using and if you are defining an NACL manually, then you can start writing the rules from 100. Okay, so if you create a new NACL, it will by default deny everything. Okay, newly created NACLs will deny everything. NACLs are great way of blocking a specific IP address at the subnet level. Okay, so we'll see here. If you see the diagram here, so this is our subnet. Okay, this is our public subnet, and inside it we have a security group, and inside it we have an instance. Okay, the EC2 instance is already assigned to a security group, and this subnet is assigned with a NACL. Okay, so what happens is when you get an inbound traffic, it goes to the NACL and see if this particular traffic is allowed or not. Okay, so when this particular traffic is allowed based on these rules, if it is allowed, then only it enters into the subnet. Okay, so after entering into the subnet, again it will check in this security group. Okay, so if the rules, if an IP is allowed in the NACL and if it is denied in the security group, then also it won't enter into your EC2 instance. Okay, so this is something like a two-step verification. Okay, so it checks here, and again when entering into this particular subnet, it will also check the rules in the security group. Okay, so it enters into the security group, and when the EC2 instance or the security group, okay, allows, it goes to EC2 instance, and from this EC2 instance, it again gives a outbound traffic from the EC2 instance, and the NACL also checks the outbound traffic. So if you deny any, okay, traffic, outbound traffic in the NACL, it won't allow to get the traffic outside the subnet. Okay, so in the security group, if you define only inbound rules and if you don't define any outbound rules, still the EC2 instance will, okay, send the response back to the requester. So this is something called a statefulness. Okay, so this is how we say EC2 instance security groups are stateful, but NACLs are stateless because you need to, okay, define the outbound rules also. It by default it won't take any default rules. Okay, so NACL, we need to define the, okay, outbound traffic firewall rules also. Okay, so this is one important thing. So NACLs are stateless and EC2 instance security groups are stateful. Okay. Okay, so this is about NACLs. So when you come to the outbound request, so here we have seen how the incoming request enters through NACL into the security groups, and it enters into the EC2 instance, and how the EC2 instance sends it back the outbound traffic, and how the NACL controls it here in the subnet level. So if you see about the outgoing traffic, so when the EC2 instance sends a outbound traffic, it goes to the security group, okay, and again it goes to the NACL. So this is something like the EC2 instance inside the subnet is requesting something from the outside. So it is sending a request outside. So then what happens? It checks the outbound rules, okay, and again it checks the outbound rules which are defined in the NACL. And when the requesters give the response goes to the NACL, okay, and again it will check whether the inbound traffic is allowed or not in the NACL, and it enters into the subnet. Whenever this is passed, it entered into the subnet, and it again checks the EC2 instance security group whether the particular inbound traffic is allowed or not, and it goes to the EC2 instance. Okay, so two things you need to remember here. So one is the NACLs are security groups similar to security groups, but which acts as a firewall for the entire subnet. Okay, but the security group is something which acts as firewall for the EC2 instance. Okay, so for every subnet we can have one NACL. Okay, and other thing you need to remember is these NACLs are stateless. Okay, and this EC2 instance security groups are stateful. Okay, so these are the three things you need to remember. Okay, so as we said, like we have seen all this. So here, if you see, there is an example here. So this is the architecture which we have already built. So we took a VPC, we have public and a private subnets, which we have already created, and we have created some instances in security and security groups in these two public and private subnets, and we have see what is internet gateway, and through internet gateway we are providing our internet access to our EC2 instance in the public subnet. Okay, and again we have created an NAT gateway, and using this NAT gateway we are providing internet to this private subnet security instances in this private subnet. So this is what we have already done. So here we have see here we can see there are two NACLs. So for each subnet, we are assigning one NACL. Okay, so this particular NACL is assigned to public subnet, and this is for private subnet, and it allows the traffic into the subnets. Okay, and this is for the subnet level. Okay, so we'll see what is, so by default when we create a VPC, we'll get a default NACL. So what is in this default NACL, we'll see. So in the default NACL, by default it accepts everything inbound and outbound with the subnets associated with it. Okay, by default it allows and denies. So it allows all the inbound and outbound traffic up to the subnet. So it is recommended not to modify the default NACLs. Instead of, if you want to do anything, you can create a new NACLs for your EC2 for your particular subnet. Okay, and this is also one thing you need to understand. So this ephemeral ports. Okay, so what is this ephemeral port means? For any two endpoints to establish a connection, there must be using some ports, right? So say like if you are running any web server in your EC2 instance, if you want to connect it, okay, from your client system, so there must be some ports that need to be opened from the in the server through which the client will connect to the server, right? So if you are using an HTTP website, then you need to open port 80. If you are using HTTPS, then you need to open 443. If you want to connect to your server using SSH, then you need to open port 22. Okay, so for connecting from client to server, there are different ports, right? Okay, so based on the protocol which you want to connect, so there are different ports that are being opened. Okay, so clients are connected to a defined port and expects a response on an ephemeral port. So whenever you are connecting to a web server, then you are okay connecting through a fixed port based on the protocol. But when the web server is giving you a response to the client also need to open some port, and it should be ready to uh, receive the request from the response from the server through that port, right? So that ports which the client is opening to receive the response from the web servers after a request. So those ports are called ephemeral ports. Okay. So here you can see clients connect to a defined port and accepts a response on a ephemeral port. So this client, okay, so when it do a request, okay, so say like this might be a HTTPS request. So here the source IP is 11.22.33.44. So and the source and here the destination IP is 55.66.77.88, and the destination port here, the server port, it is doing a HTTPS call and the port is 443, and it is sending a payload, and it also send a port called ephemeral port called 50105. So when a client sends a request to the web server, it keeps all this in the headers. That means it will send the source IP, destination IP, on which port it need to connect to that server, and what is the data that payload data that it needs to send to the server, and what is the ephemeral port. So this ephemeral port is something which that is also received by the web server. So then what this web server do is it will process the request, and it will send the response. In the response headers, the web server also sends what is the destination IP that it need to send to the send the response. So what is the source IP? So this is the source IP, and on which port it receives the request. So in which port it received the request, and which port it need to send the response. So this is the destination port. So it sends the response to this particular client on this ephemeral port, and this client receives this response on this port. Okay, these ports are called ephemeral ports. Okay, so you need to understand this because this will be helpful for in our hands-on session. Okay, so in different operating systems, these different ports ranges will be, and this ephemeral ports ranges will be different. Okay, so if you go for AN and Micro and Microsoft Windows, okay, so this will be mostly from 49,152 to 65,000, okay, 535. So if you go for many Linux kernels, these ephemeral ports will be a range from this particular range. Okay, so these ephemeral ports are not fixed ports. Okay, because they are like dynamic ports which are by default assigned in a ad hoc manner. So there will be a random port between any of this number. Okay, so how we'll do this NACL with ephemeral ports? So say like we have a in a VPC we have a public and a private subnet. Okay, so whenever this public instance do a request to a instance in DB, right? So here we are doing a request from the public subnet to a private subnet. So here we have a some say like we have some EC2 instance which is doing some request. So database request. Okay. So this database runs on port 3306. Okay. So whenever we put a request, so this request goes out from the subnet. That means it goes through the NACL. So in the outbound rules, we need to provide the port. So we need to define the port in the outbound rules of this NACL, saying that this particular subnet do a outbound request to database which goes on 3306. Okay, this to be defined in the NACL here. Okay, and here also we need to define a rule in the NACL saying that this particular subnet accepts the port 3306. Okay, into this private instance. Okay, so we do a request here, it check the outbound rules and it goes here and it check the inbound rules and enters here. So till here it is fine because we know here we are connecting a particular database and it runs on port 3306 and we define this particular number here. Okay, but it gives the response to this again in a ephemeral port because it also uses some port number which is called ephemeral port. Okay, but these are not fixed. So what we'll do is we will put a range of ports in the knuckle here. Okay, saying that from 10242 to 6664535. Among this all these ports you can allow the outbound traffic. Okay, so here also you should define the same, saying this particular ports need to be allowed as inbound traffic, and again this will receive the data. So if you are doing some if you are creating a knuckle and if you see there is no data no response you are getting after a request, then mostly that will be an issue of this particular ephemeral port. So that's why we need to learn about this. Okay, so finally we'll see what are the differences between security group and a knuckle. Okay, so before that, first we'll go with the hands-on session. So we'll see how this knuckles works. Okay, for that, like we'll go to our EC2 console. So here is our, I think you can see this. Okay, so here we'll go to our EC2 instance first. So we'll try to create a public. Okay, we'll try to create an instance here. So we have no instances. Now we'll create and launch an instance. So I'll say it as my public. So we are creating a instance in our public subnet, EC2 instance. Okay, so we'll go with this Amazon Linux. That's fine. So we'll go with this FreeTer eligible instance. We'll select my demo key pair. And in the network section, we'll create our EC2 instance in our demo VPC. So this is our demo VPC. And we'll keep everything same. So we'll keep this my demo EC2 instance of security group. And when everything is okay, then we'll go and launch an instance. So now our instance is getting ready. So we have this public IP, okay, and this is created in our public public subnet. So now my instance is running. Let's connect to it. So I'll go and connect it. So we need to do a couple of things here. We'll install the HTTP server and we'll run a web page here. So here what I'll do is I'll switch to root. Okay, I'll keep this big so that you can see. I hope you can see this now. So now what I'll do, I'll write this, I'll install this HTTP server. So yum install httpd -y. So this will install a web server, Apache server in our instance. So it is installed. So clear it. So we'll say service httpd start. So now we can see the status. So httpd start. So we'll see. So now it is running and it is active. So we'll clear this. So I'll create a web page here. So say like echo hello world, and I'll put this in /var www html desktop. I'm just creating a web page here. Okay, so now what we'll do is we'll go to this EC2 instances. So I'll get a public IP here. So I'm copying this public IP and if I put it here, so it is not connecting. So we need to check the security groups here. So here we have a security group. We'll go to a security group and allow the traffic. So now only port 22 is allowed. We'll add another port. So now we'll say HTTP port, allow HTTP port. So now I'm allowing it from all the traffic. Okay, so I'll save the rules here. And if you run this, so now you can see we are getting an output called hello world. So now we are able to access our particular web page. Okay, so now we'll see. So here we have created a sample instance, in which it is running an Apache server and it is running a HTML web page is getting triggered when you run this server. That means like it is accessible to this HTTP port in the security group. So we haven't used any NACLs till now, so we just allowed a HTTP port in our EC2 instance. So we don't have any subnet level permissions we have defined till now. Okay, so now what we'll do is we'll go to the VPC. So I'll open another tab here. So we'll go to VPC. So in that we have, in the security tab we have network ACLs, which are called NACLs. So we'll open this here. If you can see, we have so two subnets. So we'll select this is our VPC, right? So for demo VPC, whenever we create a VPC, it will create a default NACL and it will put all the rules for all the subnets here. Okay, so we'll my demo VPC NACL. So this is my demo VPC's NACL. Okay, so if you see here in the inbound rules, so you can see by default it allows all the traffic here. Okay, so in the outbound rules also it allows everything. So we'll go and edit this. So now our particular subnet. So if you can see subnets which are associated to it here these are the subnets. So all the subnets which we created in this VPC are associated to this NACL. Okay, so we'll go here and we'll see the inbound rules here. Okay, so what I'll do is, instead of changing this default NACL, as I said, it is better to create a new NACL. So I'll see my public subnet NACL. Okay, so I'll select a VPC here. So this is my demo VPC. So I'm saying this as my public subnet NACL, and I'm creating this ACL. So after creating this ACL, we can associate some subnets to it. So I can go to subnet association and edit it, and you can add my public subnets to this NACL. So I'll save this. So now if you can see this, in this public subnet we have two subnets. Public NACL we have two subnets, A and B. So B and the other two are in this particular private subnets are in this particular default NACL. So we can leave that like that. So here we have this public subnet. So by default here also, so if you can see the default NACL which comes with the subnet, it allows all the traffic here. See, so the default subnet, the default NACL which comes with the VPC. When you create a VPC, this default subnet is created. For this, by default, all the traffic is allowed. Okay, but if you create any NACL on your own, okay, so this is my, so by default it denies everything. Okay, so we need to edit this and we need to allow the inbound and outbound. So first we'll allow the, so here I'll add 100 and I'll say, so now before this, if you go here and if you run this, see here it is not allowing any traffic because now our public subnet is connected to the NACL which we have created, and there it is not allowing any traffic into the subnet. Okay, so now what we'll do is we'll go here and here I'll create for all traffic and saying from everywhere allow save changes. So now we have allowed all inbound traffic. Okay, and if you see here and if I run this, see it is still not allowing because we have allowed the inbound traffic but we have not allowed the outbound traffic. Okay, so that means we are not getting any response inside the subnet. Okay, so we'll go here and if you edit it, let's say add rule 100 from all TCP allow save changes. Okay, so now we have inbound allow everything and outbound allow everything. So if you go here and if you run this, see now we are getting the response here. So there is no infinite loop here. Okay, so this is how the NACLs works. So apart from this, all rules you can add as other rule. So if I go to the inbound rules and if I say add new rule, and here I will add new rule call with 150 and say the HTTP traffic must be denied. Okay, or okay, see if I said like in the 150 rule number 150, I'm saying allow HTTP traffic. Okay, and I'm denying it and save these changes. And if you go to inbound rules, it will come in an order way. So in the 100 we are saying all traffic must be allowed. Okay, and in the rule number 150 you are saying HTTP must be denied. Okay, so we'll see what happens. So if you refresh, see it is giving us the response because here it takes the first rule and it gives that rule. Okay, and it follows that rule and gives the inbound access to it. So if you go here and if you edit this and if you say this something like 80, okay, and save change. So first what happens is first it goes to this rule and again then it goes to this rule. Okay, so if you go here and now if you run this, see, so it is not allowing this traffic to enter into our subnet because here in the first rule we said HTTP port must be denied. Okay, so this is how this network ACLs pick the rules on this rule number wise. Okay, So what we'll do is we'll go here, and if you remove this and save this change. So now we have removed that rule, so that now we will be able to access this. Okay. So this is how this network ACL works on a subnet level and acts as a firewalls for the subnets. Okay. So we'll go to our slides again. So what are the difference between security groups and NACL? So the security groups operates at a instance level, where this NACLs operates at a subnet level. Okay. Similarly, this security group supports allow rules only, and NACL supports allow and deny rules. Okay, so either you can, in security group, this default, by default you will give a allow rules, and remaining all the ports will be not allowed. So here we can say, so it will give, you can give allow and the deny rules. Okay, and we have seen the security groups are stateful. That means the return traffic is automatically allowed regardless of any rules. And NACLs are stateless. The return traffic must be explicitly allowed by the rules. Okay, so think of ephemeral ports. So when you one more thing. So in the security groups, if you don't define these ephemeral ports, still you'll get the response, right? So we are not defining any ephemeral ports in the security groups, but in the NACLs, you need to show by like you need to definitely define these ephemeral ports to enter to get the traffic, inbound traffic or outbound traffic. Okay, so all rules are evaluated before deciding whether the traffic need to be allowed or not. In the security group, it checks all the rules which we have defined to the instance or the security group rules. So in NACLs, rules are evaluated in order. So lowest to highest, it will check one by one. So when deciding whether to allow the traffic, the first match wins. Okay, so which we have seen just now in our hands-on applies to all the instances which are specified by someone. So, but here like automatically applies to all instances in the subnet that is associated with it. Okay, so if you create this security group and if you assign it to the EC2 instance, then only it will apply to the EC2 instance. But here in the NACL, so if you create this NACL for the subnet, okay, by default, any EC2 instance that was created in the subnet. So for all those instances, this NACL tool will be applicable. Okay, so this is one thing very important. So this is instance level and this is subnet level and this is other thing. So security groups are stateful and NACLs are stateless. Okay, so these are the things we need to remember more. Okay, so we'll see another concept now. So which is called VPC peering. So we still now we have created a single VPC. Okay, in that VPC we have created some subnets, private subnets and all. So and we tried to communicate between the public subnet and the private subnets which are available in the same VPC. Okay, so here the VPC peering is like privately connect two VPCs using AWS network. So say like we have VPC A and VPC B. So if you want to connect the instances which are in VPC A and we need to connect them from VPC B. Okay, then we need to create a VPC pairing between A and B. Okay, so that now we can access all the instances in VPC B from A and A from B. Okay, so VPC pairing make them behave as if they were in the same network. Okay, so this particular okay network transfer or the communication happens in the private network. So because like we know these VPCs all are created inside AWS and AWS is a okay cloud network and all the instances which are created in the AWS they can talk each other through using private network. Okay, through private IPs. Okay, so this VPC pairing communicates with each other using private network of AWS. Okay, it won't use any internet or the public IPs. Okay, it will connect through private network of AWS. So, and this make them behave as if they were in the same network. Obviously, they are in the same network, but they are created in different VPCs. They are in the AWS network. So they will be when you create a VPC peering between two VPCs, they act as like they are in the same network. Okay, so they must not have any overlap CIDRs. So that means for each VPC we are giving a CIDRs, right? So for VPC like which we have created, we have given a CIDR like 10.0.0.0/16. So okay, those CIDR blocks must not overlap in this other VPC pairing. Okay, so if there is any overlapping, then there will be same IPs in the two VPCs. Okay, so these CIDRs must not overlap, okay, between two VPCs which you want to create a VPC pairing. So VPC pairing connection is not transitive. So that means it must not establish for each VPC that need to be communicated with the, it must be created for each VPC that need to communicate with each other. So that means if you want to create a VPC, so if say like there is a VPC A, B, C, and we have VPC pairing between A and B, and other VPC pairing between B and C. So with these two VPC pairings, we cannot pair between A and C. So we need to again create a VPC pairing between A and C. Okay. So this is which we call not transitive. Okay. So here if you want to create a pairing between any two networks, there must be definitely a VPC pairing. Okay. So you must update route tables in each VPC subnet to ensure EC2 instance can communicate with each other. So after creating this VPC pairing, you also need to update the route tables in these two VPCs so that this particular VPC A must allow all the instances from VPC C, and all the VPC instance must be allowed in VPC A route table. Okay, so we need to, okay, edit the route tables also to allow or deny the, to allow the traffic between these two VPCs. Okay, so how this VPC pairing works, we'll see. So here this is the VPC which we have created, and inside the VPC we have all these public subnets, NACLs and all. So here outside there will be some other VPCs. Based on this, we'll create a VPC peering connections on the VPC level, and we'll peer this to this other VPC in the AWS that might be in the same region or that might be in the different regions. Okay, so VPC peering can be happen within the same region or within the different region or within different AWS accounts. So say like I have one AWS account and you have another AWS account, so we can communicate between these two AWS accounts and two VPCs. Okay, so that can also be done using VPC pairing. Okay, so we'll see this on hands-on. So here we have our VPCs here. So here we have two VPCs. This is the default VPC which we got from AWS, and this is our demo VPC. So what else? I'll rename this as default AWS VPC. Okay. So now we have two VPCs here, and we have one EC2 instance which is already created. Our okay, we have already created a EC2 instance in my demo VPC. So we'll again create an EC2 instance in my default VPC. So okay, we'll go to EC2. So we'll create another server, other instance. We'll launch this new instance. We'll say AWS default VPC instance. Okay, so we'll create here. So we'll use the same key pair. And here we are using, now we are using the default AWS VPC to create the server. So we already have a EC2 instance in the demo VPC, and we'll create a server here, and we'll try to communicate between those two. Okay, so we'll keep everything like this, and we'll use the same security group. So we'll create a new security group, and we'll launch this instance. So it is getting, so now I'll open this. So I already have this. So this is our EC2 instance which is in our demo VPC. So I'll close this, and this is our new instance which is in the default VPC. So meanwhile, if you go and see here, so for these two instances. So if you see, this is my demo VPC instance or demo VPC instance, and this CIDR is something which we have defined here. If you go to the default VPC instance here, the public IP is starting from 172.31 because this public CIDR is like 172.31.0.0/16 or something. So this is the private IPs which are being created in the AWS VPC. So we have something like different from our 10 dot something. So this is our demo VPC instance, and this is our AWS default VPC instance, and we got the public IP here and it is running. So we'll connect to this also. Okay, so now here, so this is my demo VPC, and this is the default VPC of AWS. So here what we'll do is, so here we are already running a HTTP instance, right? So what I'll do is curl and say like 10.0.0.14 port 80. So if you see here, if I do a curl command with the private port, so I am getting a response. Okay, because anyway, this in this instance we are already running a Apache server, right? So in this we are running an Apache server, and if you access it through this private IP, we are able to get the response here. So if you use this same curl here, and if you see, so this is my AWS default VPC EC2 instance. So here I'm not getting any response. Okay, so we are not able to connect to this EC2 instance which is in the other VPC. So now what we'll do is we'll create a VPC peering, and we'll create a connection between these two VPCs and these two instances. So for that we'll go here and we'll go to VPC again. So here that's VPC, and if you go all the way here, VPC peering connections. So if you can see here the peering connections, open this and we'll create a new peering connections on click on. So my demo VPC peering. Okay, so we need to select the VPCs from which who is the requester and who is the acceptor. So here I'll say my demo VPC will be requester. So this is the CIDR of our demo VPC which you have created, and this is in my account only. If there is any if it is in any other account, you need to provide the account ID here. So now it is in my same account, and it is also in the same region. Okay, so if it is in another region, you need to select the region and the VPC, and it is in the same region. So this is my default AWS VPC, so which I want to connect the peering, and here this is the CIDR. So if you can see, this CIDR is not overlapping this CIDR, so this VPC connection is possible. So the name is fine, and I'll say create peering connection. So now we have created a peering connection here. Okay, so and here it see a VPC peering connection is been created. So now if you see the route tables, we need to update the route tables for this. Okay, so before this you need to see here. So whenever we create a VPC connection, so only a request will be sent. Okay, so we need to accept the request. So here the requester and the receiver both are in the same account, so I can go here and accept the request. So if it is in the different, the requester is in different account, then those requester will get this page. Okay, then he need to accept the request. So I'll accept the request, and it will show all the summary here, and I'll say accept the request. Okay, so now the request is accepted, and here if you see, it is saying your VPC key peering connection is established, and here to send and receive the traffic across the VPC peering connection, you must add a route to the peered VPC Okay, one or more to our VPC route table. So it is saying something like you need to update your route tables so that it allows the traffic, okay, from the requester and the receiver VPCs. So I'll go to my route tables now. So here we have our route tables. So here I'll select my default AWS VPC. So this is the default AWS VPC route. So this is my default AWS routing. So first I'll edit it here. So we'll go to the routes. Here we are allowing only this. So we'll go edit. We need to copy the CIDR of this particular. So this is the default VPC route table. Okay. So in this default VPC, we need to allow our demo VPC CIDR. So we'll go here and add and say if you get any traffic from my default VPC, demo VPC that is running in /16. So if you go here, uh, if you go to the VPCs here, so here see the CIDR of our demo VPC is this one. So I'll allow this here, and whenever we get a traffic to this particular VPC from this CIDR, so we are saying to peering, we are redirecting it to the target of peering connection and to this peering connection, and we'll save the change. Okay, so and similarly you also need to allow in the demo route table also. So we'll go to this demo VPC router. So my instance is in public, okay, public routes. So I'll go to this routes and I'll say I'll also allow this because it need to give the response, right? So if you see here, if now if I run this, it is not allowing any traffic here. So what I'll do is I'll go to this EC2 instance again. Now I need to allow the AWS default CIDR to, okay, I'll give the AWS default CIDR, and here we'll select a peering and we'll select our demo peering connection and we'll say save changes. Okay, so now if you go to, so this is okay, so this is our AWS VPC instance. So now if you can see, so now we are getting the response from the, okay, other VPC. So now the peering connection is been established and now we are able to access this particular, okay, server which is in the demo VPC from this server which is in the default VPC of AWS. So now these two VPCs are connected and they are able to, okay, communicate between each other. Okay, so this is how this VPC pairing helps. Okay, okay.